Yesterday we learned how to graph a quadratic function on a coordinate plane. Today we're going to look at solving a quadratic inequality using a number line. So we'll have one variable, just our x variable, instead of two, like yesterday we had x and y variables. So first we've got a little bit of vocab, and that is critical values. These are numbers that divide the solution region from a non-solution region. So thinking about a regular inequality, if we had 5x minus 2 equals 15, less than or equal to 15, and we solve this, when we graph that on the number line, the 17/5 is our critical value because it would be a solid circle because it's a less than or equal to, and we would shade to the left because it's less than. So the value of 17/5 divides our number line from the solution to a non-solution. Now with a quadratic inequality, we're going to have more than one critical value, and we'll see how that works. All right, our essential question today is how can you algebraically solve a quadratic inequality? Yesterday we looked at how to graphically solve a quadratic inequality. All right, so step one, we want to set it equal to 0. What we're going to do is solve our quadratic inequality using the factoring or quadratic formula. Adding 3 to both sides. And the first thing, the easier way to solve this one is if you can factor. It's faster, especially when the lead coefficient is 1. So check for factoring first. If you can't find a way to get it to factor, then use the quadratic formula. That will be your backup. So T-chart method, what multiplies to 21 and adds to -10, and that will be -7 and -3. So this is the shortcut where we can just throw them into our binomials. And then we're multiplying to 0. So we can go ahead and use our zero product property to solve for x. Again, I'm using equal signs because these are finding the critical values, and these are the numbers that we will graph on the number line. Then we will figure out where to shade. So we get x equals 7 is our first critical value, and x equals 3 is our second. So step 3, we're going to go ahead and graph these on our number line. And looking back at the original inequality, it's less than, so these will both be open circles because they will not be part of our solution set. And then we're going to test a point in each region, similar to what we did yesterday. We tested a point inside the parabola and a point outside the parabola to figure out where to shade. We're going to do the same thing today. So I'm going to start with 0 because that's the easier number to work with. And I'm going to go ahead and use the one where I already added 3 to both sides. So is 21 less than 0? No, so we will not be shading to the left of 3. So then we pick a point between 3 and 7. I'll go ahead and test 4. So substituting 4 for x. Is 16 plus 21, which gives us 37 minus 40, less than 0? Yes. So we'll shade in between 3 and 7. Most likely, numbers greater than 7 will not make it work, but we have to test one just to be sure, so I'll grab 8. Alright, so we have 64 plus 21 is 105, minus 80 is positive. So no, that is not true, so we will not be shading to the right of 7.